We're going to go through synthetic division, and we're going to divide this polynomial with our divisor of x plus 1. So when we go to set up our synthetic division, we're strictly actually looking at, that is backwards, but I'll fix it if it's right. We're strictly looking at this value here. We're not looking for the constant itself, which we normally do in long division. I'm going to double check that to make sure it's right. So we go to set this up. It kind of looks like an upside down long division. We take all of our coefficients, so positive 3, positive 5, negative 2, and positive 3, and we write them in. So we have 3, 5, negative 2, and positive 3. We take this value, R1, and what we're going to be doing is working with subtraction across this line. So I draw a subtraction sign to remind me that we subtract all the way across here. Now on the bottom of this, I'll put that little bit there, we're going to be multiplying. Okay, so I'm going to put a little multiplication sign to remind me that every time I get a value in this column, I'm going to multiply it, okay, by this number here and bring it back up. So it's going to have this similar idea to it. So with that being said, the very first coefficient, that's fine, we bring straight down the value of 3. So we have 3. Okay, there's nothing there. Assume that that's the idea of we're subtracting 0. So 3 subtract 0 gives us 3. So I now take this 3 and I multiply it by our positive 1. Well, that gives me 3 again. So we're left with positive 3 here. Okay. Then we go into our subtraction again. Okay. So 5 subtract positive 3 is going to give us our value of 2. Same idea. We take 2 and we multiply it by our 1. What will that give us?
2.
Yeah, give us positive 2. Great. Positive 2, we go to subtract this from negative 2. What will that give us?
0.
Think of it again. I know it looks hard from this version, but it's negative 2 subtract positive 2. Okay? So think of it like negative 2 minus negative 2. Yeah, so we get negative 4. Excellent. So we end up with negative 4 in this case. Take that same idea, negative 4, multiply it by our 1, and we're still going to get negative 4. And now this one is a little simpler to work with because this value here happens to be 1. And we subtract those values again. Positive 3 subtract negative 4 gives us, yeah, positive 7. So the value at the end here is important. That's our remainder in this question. Okay, so we know we have remainder 7. This is essentially synthetic division. That's the quick and easy part of it. We only have to work with one number at a time instead of multiplying the entire binomial like we normally do with long division. But let's say this was unknown in this question. Okay, so let's rewrite the same question, and they've given us instead p at x is equal to, we'll call that k, x cubed plus 5x squared minus 2x plus 3. Okay, and we'll say that they told us we had a divisor of x plus 1 and we had a remainder of 7, but we were unsure what the original coefficient to the x cubed was. So we have to work backwards. Okay, so we're going to set this up synthetically, the exact same idea. When we set it up synthetically, we take all the coefficients. Okay, so first coefficient is the value of k. The second one is 5. The third one is negative 2. The last one is positive 3. We know, like they told us, we have a remainder of 7. So our actual last value here is positive 7. And if we were to set this up all properly, we know our value here is positive 1, so we write our positive 1. Everything in this row I subtract, and everything in this row I multiply. So we work backwards here. What would I subtract by, okay, to make positive 7? 3 subtract what value? Okay, you can call it your x if you want. Gives us positive 7.
Negative 4.
That's right. So we have negative 4. Okay, with that being said, we work backwards, okay? So because we would have had to multiply this value here by our 1, and because it's 1, it's very straightforward. Had it been another number, there would have been a little mental division we'd have to do. But because it's 1, it's simple. Positive 1 times what gives us negative 4?
Negative 4.
That's right. So we know that this value was negative 4 here. Okay, great. We got that. Let's work backwards again. Negative 2 subtract some value gave us negative 4. Negative 2 subtract what gave us negative 4?
2.
Yeah, positive 2. Great. So we have positive 2 here. Same idea. That means this would have been the value of positive 2. 5 subtract what value gave us positive 2?
Positive 3.
Positive 3. Great. So we have positive 3, which means this value must have been originally 3. And remember, when doing synthetic division, we take the original down and bring it straight down. So that meant our k value would have been 3, which is exactly what we had started with. This value was 3. So we were able to actually use synthetic division and then reverse it. As long as they gave us the idea of the remainder and the divisor, we could find any of the coefficients by reversing the process of synthetic division. Does that make sense? Okay, with that same idea, if we want to solve k in this question, we can go about this in a very simple way. Now, our p at x, we know the factor we're using here. And to find the factor, we would essentially set this equal to 0. The factor in this case is x is equal to negative 1. So, with our remainder theorem, what that's saying is p at negative 1 is essentially equal to the value of 7. So if that's true, we're going to take our function notation down here, okay, and p at negative 1, and remember that we can replace this p at negative 1 with a value of 7 after. We're going to plug negative 1 into all these values, so we have k times negative 1 cubed plus 5 times negative 1 squared minus 2 times negative 1 plus 3. Okay. So with that being the case, I'm now going to replace 7 with our p minus 1 because we know we have a remainder of 7 in this question. So 7 is equal to k. When we cube this, we get negative 1. This becomes 5 times 1. This becomes positive 2 plus 3. And now that we've done that, our goal is essentially to isolate k, which is much simpler than reversing long division or reversing synthetic division to solve for our k factor. So when we do this, this becomes negative k. We move all our other factors to the other side. They become 7 minus 5 minus 2 minus 3, it looks like. I feel like I've done that wrong. 7 negative. Oh, no, that's right. Okay, good. I was a little concerned here. 7 minus 5 is 2. Minus 2 is 0. Minus 3 is negative 3. So we have negative 3 is equal to negative k. And to get rid of the negative, we divide both sides by negative 1. We get k is equal to a value of 3, which is exactly what we'd found in our previous question. So instead of reversing synthetic or long division, we can plug our value in, set it equal to our remainder, and isolate our unknown coefficient.